Alright, so this is my friend Elias. Say hi, Elias.
Hi.
Alright, I'm gonna ask you 7 questions, okay, Elias?
Sure.
And this is for my physics project. Alright, so just tell me what you think, okay? Alright, so number 1. If I drop 2 objects that are 10 kilograms from 100 feet, but one's a sphere, so if I drop a sphere and a cube that are the same weight, which one will hit the ground first?
A sphere or a cube?
Yeah.
It's a sphere.
A sphere? Alright. I'll take that and consider. Alright.
Well, I'd say the sphere because those is kind of different. Let's say you jumped into a pool and did a pencil, you would hit the ground faster than a belly flop because you have less space with your like tip with your feet than your belly, you know?
Yeah. Alright.
Sphere of the cube?
The sphere or the cube?
It's the cube.
You think the cube? Alright.
The sphere will hit the ground first
And why do you think that?
because there's less resistance.
Neglecting friction?
Yes.
They hit at the same time with friction? So the sphere will hit first.
Okay. Second question. How does a boat float? Why doesn't it just sink since it's way heavier than a rock or something similar that sinks?
Because the substance that it's made out of has air in it, and it floats because of the air in the substance, like wood has air in it. So even though it's heavy, it's the way that it's built and the substance makes it float.
Okay.
I don't know why though.
So next is, how does a boat float? Why doesn't it just sink? It's way heavier than a rock or something that does sink.
Because maybe possibly a boat has sort of hollow-ish, and a rock is completely non-hollow and full, so a boat has a smooth. Let's just go with that. In the
water, yeah, in the water.
Because it floats because when it's in the water, it can't just float by itself. That's why you have a pedal, and then you do this something go.
Nice, I like that answer. I like it. I like it. How does what?
Some type of force.
Some type of force? Alright. Works for me.
Archimedes' principle.
What's that?
The displacement of water versus the weight of the boat. So it's more buoyant.
Okay.
So, if 2 football players run at each other, so like, say me and Keyshawn are running at each other. I'm 155 pounds, and Keyshawn's 200 pounds, but I'm running at 15 miles an hour, so I'm running faster than he is, and he's running 10 miles an hour. Who will win? Who will push the one back when we hit each other? So who will win, me or Keyshawn?
I think it would be Keyshawn because he weighs more than me, so he can just easily push him down because he's bigger.
Okay, I like that.
No idea.
Take a guess.
The bigger one.
The one that one weighs 155 pounds.
MV and MV. Figure it out. I can't do it in my head.
Okay.
I think the 155-pounder that's going 15 miles per hour would most likely knock over the other guy because, he's going faster than that guy.
The smaller one? Hey man, be quiet.
Which one will win? Which one will keep going?
When they hit each other, which one
I see.
will continue?
I think the 200-pound one will push the other guy over.
Okay, just because he weighs more?
Uh-huh.
Okay.
So how do car brakes work, Amy?
Well, you press on the pedal and bring the jig, it stops the tires.
I don't know, but...
Do you have a guess?
A guess. My guess is that when you push on the pedal, then it does something, and the friction from... It pushes something against the tire, the inside of the tire, and it's the friction that presses together and it slows the wheel down.
So it's just your foot pressing against the tire and that will push something against it?
Well, you're pushing the pedal pushes something, I don't know, a gizmo, a rod, I don't know what it is.
Okay.
And then that makes the brake pad press against the inside of the wheel, and then the friction makes it stop.
Okay.
Car brakes?
Yeah. So like the brakes on the car, how do they work?
Wait, did you?
So you know the brakes on the car, you know how your mom presses the pedal?
Oh yeah.
Well,
Stop?
Yeah, so it stops. How do you think that works?
Like when you're driving anyway and you need to stop to do something, or when you're done driving and you need to stop the car, with like inside the car there's a thing that makes it stop when you press on it with your foot.
Okay. Alright.
How do brakes work?
Yeah, like car brakes. Car brakes. How do car brakes work? Hey man, be quiet! Elias, leave. Go around, go off real quick. Oh my gosh, that's...
I can't answer that, dude.
Alright, whatever. I'll ask you the next question.
When you push on the brake, how does it stop the tire?
Hydraulic pressure pushes the brake pad against the disc, and then it will stop the wheels from spinning with friction.
How does the plane fly?
A plane flies like there's like animals they can fly like a bee or so, like because like their animals fly like this, like because they have wings, but a plane can fly because they have because you can press, because when you're inside it you can drive it like a car, but inside of the sky.
Alright, next question.
How do the wings work?
The pressure below the wing is higher than the pressure above the wing, so it lifts the plane up.
Okay.
Because it has wings.
Force, some kind of...
Alright, some force.
Yeah, some type of force.
Alright.
I don't know how to explain that. My guess is the what's it called? Combustion? The
engine,
that makes it take off. So it's just the power, a lot of fuel. The power makes it take off, right? Because you can push against gravity. And then to keep it up in the air, it's the lift. It's something to do with air, the way that the wings are positioned, and so when you're pushing it against the air goes underneath it a certain way, and it makes it lift.
Okay. Is it better for a car going 50 miles per hour to hit a brick wall head-on, or another car going 50 miles per hour in the opposite direction?
It would be better to hit the other car coming in the other direction if that car weighed almost zero, because then it wouldn't even notice that it hit it. So it depends on what that car weighs as to whether or not it would do anything.
Okay.
That's my guess.
Heck no.
So the wall. So would you rather hit a wall or a car?
A wall.
Okay. All right.
I think going towards the wall because it's two moving objects going toward each other. I think it would make a bigger impact than one moving object going towards the wall.
Towards you.
Told you. All right.
Which one will have less damage?
The brick wall.
Okay, why do you think that?
Because if the other car is coming at you, the speed of that car and the speed of your car actually makes it like it's 100 miles an hour. They're going 50, you're going 50?
But the car is... What lies beyond the edge of the universe?
It's too late.
Oh.
And what? All right. So you got to use your imagination on this one. All right. You already, even though you got a big imagination. What is beyond the edge of the universe?
Is it recorded?
Yeah, it's recorded.
Say that again.
All right. So what do you think is beyond the universe? What do you think is out there right now in space? In the universe?
I mean, astronauts.
Astronauts? Alright. Alright, thanks a lot, Elias.
Like Earth or the whole universe?
The whole universe. What do you think is beyond the... Immense!
Another universe.
Another universe. Alright, this is Schmarky. He just answered.
Chocolate.
Okay.
At the edge of the universe?
Yeah. So if you got to the edge of the universe and kept going, what would happen?
You would I have no clue. You would be in eternal kismet with the rest of everybody.
Okay. Thank you, Mom, for answering all these questions.
You're welcome.
And
that was fun.
I think there is something beyond the edge of the universe. Yes, yes.
So, that's where all the dead people are. You know, when you die and you go into the light, that's where you go.
It wraps upon itself, so you come back to the start again.
okay.
I have no idea, Jason. You'll have to tell me that answer.